last week, we have completed network fundamentals as per our schedules. The first week, we have to discuss about network fundamentals. The day one, we started basic introduction part of what is networks, importance of network, types of network. And day two, how to build a network. So what are the requirements to form a network, like an IC, media, networking devices, IP addressing, which is logical addressing, and protocols. So one by one, we clearly discussed with IPv4, IPv6, all the logics in IPv4 and IPv6, and we started discussing about how data moving, how data transportation is happening from one device to another device, like using a TCP/IP protocol. So how TCP/IP works to understand in 1984, ISO developed one reference model, which is OSI. That OSI consists of 7 layers. Top 3 layers we call software layers or we call user support layers. In the bottom 3 layers we called hardware layers or we can call network support layers. In the middle, which is transport layer, is a core layer of OSI. So in our previous class, we have completed discussing about application layer responsibilities, like data flowing from application. Application layer is the responsibility of providing an interface to the users to interact with services, and data flow to next layer, presentation. And presentation layer is the responsibility of providing standard format to the data like encoding, decoding, encryption, decryption, compression, decompression, and data flow to session layer. Session layer is to maintain the sessions, like establishing session, maintaining session, terminating sessions. Every session is identified by session ID or interaction. So we have completed about transport layer, right? So transport layer has a major responsibilities. So it is identifying service, multiplexing, demultiplexing, segmentation, sequencing and reassembling, error correction, flow control is all the responsibilities of transport layer. In transport layer, there are two protocols. Remember anyone? So what are the transport layer protocols?
TCP and UDP.
What is the difference between TCP and UDP?
I think it's wired and wireless or something like
Oh
that.
my God, no man, no. It's not at all like
Uh,
that actually.
Controlled or uncontrolled?
TCP is connection oriented.
Yes,
TC
connection. I'm
UDP is
sorry. Yes.
connectionless.
Yeah.
Connection
TCP
oriented
is
means what?
three-way handshake. Um,
Three-way handshake, excellent. So TCP always data transmission through mechanism called three-way handshake process. In TCP three-way handshake process, what is the first packet?
Acknowledgement.
Synchronized packet, SYN.
Oh, sorry. Synchronize. Yes.
Second packet is synchronized acknowledgement,
Synchronize.
SYNACK. Again acknowledgement. So three packets, SYN, SYNACK, acknowledgement. So once three-way handshake process is done, then connection is established between the source and destination device. Then data transmission is started actually. So this is how TCP works. In case of UDP, no three-way handshake process. Unreliable communication. No acknowledgements. Got it? Yeah. So like this, transport layer works, and from today we'll continue with bottom 3 layers, which is network layer. So where data generated? Application layer. This is a data packet. So data flowing from application to presentation, presentation to session, session to transport, transport to network. So currently data packet is in which layer? In network layer, right? Now here I have one small question. Out of all 7 layers, Which layer is the responsibility of identifying service? Which layer is the responsibility of identifying service?
Clear.
Yes?
Network layer.
Transport layer is the responsibility of identifying service now. Remember? Transport layer. So what is the first responsibility of transport layer? Identifying service. Correct? So same question. Out of 7 layers, which layer is the responsibility of identifying service?
Transport layer, L4.
Transport layer, right, Jaydeep? But now data is under which layer? Now data is in the network layer. Can network layer identify this data is belongs to which service? No. So to avoid this type of issue, what transport layer is doing is before sending a data packet to network layer, it is adding some additional information. We call it is headers information. So data plus it's adding TH means transport headers. Transport header. This transport header contains information about this data packet belongs to which service. Means source port number and destination port number. Source SRC, source port number DST, destination port number. So finally, data plus transport header both combinedly we call it is segment. So this segment will come to network layer actually. So network layer received what? Segment. Then what is segment contains? We know segment contains what? Transport header plus data packet. Then what is transport header contains? Source port and destination port. Got it? So we'll continue with network layer. What are the network layer? Transport layer protocols. Transport layer protocols are TCP and UDP. What about network layer protocols? Example. Here I have one scenario. Scenario is all branches, branch A, branch B, like ABC, all the routers. A LAN network is 10 dot network, and H router LAN is some different network, 192.168.1.0 network. The point is how to reach from A to H. That is the scenario actually. How to reach A LAN to H LAN is this is the scenario, A to H scenario. A network layer, let's understand, which is layer 3. So point is, router A is in 10 dot network, router H is in 192.168.1 dot network. Both are in same network or different network?
Different networks.
How
Different
it is
network.
same network? It's a different network, right? Then which device must require to enable communication between two or more different networks?
Router.
Router. So the device which works in network layer is router. Router is network layer device, or router is layer 3 device, because network layer is the layer 3 now. Physical layer is layer 1, it's layer 2, It's layer 3. So we are talking about router. Router is a layer 3 device. Router is a network layer device. How router works? What is the job of router? A router enable communication between two or more different logical networks. Means router works with IP address. It can be IPv4, it can be IPv6. So even IP address also will comes under network layer. We call network layer, layer 3 address is IP address. But point is here, from A to H scenario, how many paths are available?
3 parts.
3 paths. So whatever the data traffic is generated from A LAN, all the data traffic can go via, can exit via serial interface. So traffic will exit from serial interface. It will reach out to B, B hand out to H, and H hand out to LAN. This is one path. So via serial interface 0/0, you can reach out. Or traffic can exit via 0/1 to C, C to E, E to H, and H to LAN. This is another path. Or still you have one more path is there. We can exit via serial interface 0/2 to D, F, G, H, LAN. So from A to H scenario, there are 3 available paths. So which is the best path? 0/0 is the best, or 0/1 or 0/2? Which one is the best path?
0/0.
So okay, like 0/0 is a best path. Right, Aishwarya. The point is, the overall bandwidth in 0/0 is it's a 2 Mbps. And 0/1 it is 80 Mbps link. On third link it is 60 Mbps link. The same question from A to H, which one is the best path right now?
0/1.
0/1.
And
But just before you decided best path 0/0, but now you change your opinion to 0/1. Why?
so you mentioned bandwidth.
I have mentioned a bandwidth. Correct. So earlier you decided a best path based upon number of routers count. Agree?
Yes.
Yes. Like initially, like ABH, only less number of hops, less number of routers to cross actually, less distance. But now we are deciding best path based upon bandwidth. Oh, it is a 2 Mbps link, it is 80 Mbps link, it is a high speed bandwidth link. If your traffic is going via 0/0, we can have a faster communication. Agree?
0/1.
So, yeah, what we do in the real time means, as a network engineers, we no need to be select a best path. We implemented protocols in the routers. So that protocols will find the best path automatically. So that protocols we call routing protocols. So we need to implement which protocols? Routing protocols. So just configure routing protocols in all routers. That's all. Then these routing protocols is used to for what purpose? Used to find best path. Best path selection. Routing protocol used to find best path. Examples of routing protocols. RIP, Routing Information Protocol. Next, Open Shortest Path First Protocol, OSPF, like we have, etc. Many protocols are there. So you just implement routing protocols in this topology, then protocol will find the best path automatically. That can be 0/0, it can be 0/1, it can be 0/2. Because finding the best path, not only number of routers count, not only bandwidth, there are many parameters are involved. How much it reliable, how much packet loss, how much traffic in the link, how much load on the link. These all the things need to be considered actually. Okay. So what we do, we implement routing protocols. Yeah. Okay. So after finding the best path selection is done. Example, as per routing protocols, let's say 80 Mbps is the best path. So once find your best path, now data need to be carried to destination. So that data carriers are routed protocols. So two protocols works under network layer, which is routing and routed. Routing is used to find best path determination purpose. Routed protocol used to carry user data carrier. Examples of routed protocol is IP, IPX, AppleTalk. These all are a routed protocol. Is used to carry user data. Okay. It provides logical addressing and path determination, which we call routing. Protocols that works in this layer are a routed protocol used to carry user data between hosts. Routing protocol perform path determination, which we call routing. Okay. Yeah. So data flowing from application to presentation, presentation to session, session to transport. What transport layer will do before sending a data packet to network layer?
Transport header.
It's adding headers. Transport header. What is transport header? Contains information about
Source and destination port details.
port details, source and destination. Like transport header plus data, combinedly what we call
Segment.
segment. Right, Giri? So it's transport header plus data, what we call segment. Segment is flowing to network layer. You know what network layer will do? Network layer is also adding headers information, which we called NH, means network header. Network layer, what are the segment is received from transport, is adding more header, which is what? Network header. So what is exactly network header contains information? Network header contains information about SRC, source IP address, because routers works with IP address. Routers comes under network layer. Source IP address and DST, destination IP address. Source IP segment plus network header, both combinedly we call it is packet. So packet comes under network layer, segment comes under transport layer. What is packet contains information? Packet contains network header plus segment. Network header contains source and destination IP address information. So it's adding NH, network header plus segment we call this a packet. So packet will flow to next layer, which is data link layer. And device that works at network layer is router. Router is the layer 3 device, router is the network layer device. So routers enables communication between two or more different logical networks. This is all about router section. So which protocols comes under transport layer? What are the transport layer protocols?
TCP and UDP.
What are the network layer protocols?
IP.
Routing protocol and routed protocol.
Yes.
Network layer protocols are what? Routing and routed. What is use of? What is the use for routing protocol?
Finding a base path.
Yeah. Finding a best path. Examples of routing protocols?
Bandwidth, number of devices,
RIP and OSPF.
RIP
RIP and OS.
and OSPF. Right. Routed protocol. One more is routed protocol. What is the purpose of? What is the use of routed protocol?
Carry user data. Carry the user data.
Yeah. So next is data link layer. Now data flowing from application, presentation, session, segment, packet to data link layer. Now what data link layer will do? After the packet is received from network layer, in data link layer, it provides reliable transit of data across a physical link. It also provides error detection using CRC. Error correction by transport layer. Error detection by network layer. Two things here. Data link layer will error finding the errors, detection the errors. If it found any error, it will send to transport layer. Transport layer will correct it. Error correction and send back to network to data link layer like this. If no error, so data link layer will do what? Whatever traffic is flowing from application, presentation, session, transport network and come to data link layer. Now what data link layer? Data link layer finally it will check if the data packet have any errors or not. If no errors, it will send it to physical link and physical to destination device. It found any error, it will send back to transport layer and it correct it. Then forwarding is a method. But how it finds the error actually? So to detect the error, data linker will use one protocol help called CRC, cyclic redundancy check. By using CRC protocol, it will find the error. So the protocol involves, which protocol comes under data link layer? Data link layer protocol is CRC, cyclic redundancy check, to detect the errors. Okay. So, but which device comes under data link layer? A device which works under layer 3, layer 2, layer 1. Layer 3 route device is what? A router which works with IP address. So device works under layer 2 is switches. Switches can't understand IP address, works with MAC address. So switch is a layer 2 device. Switch is a L2 device we called. L2 device means layer 2 device. And switches works with MAC address. It does not understand IP address. It's understand only MAC address. Based upon MAC address, it will forward the traffic. Routers understand IP address. That is why routers has a mechanism to enable different network communication. Switches don't have that communication. Only same network communication is possible. Because of switches don't understand IP address, only MAC address. Got it? So flowing packet to physical link, even data link layer also adding header and trailer information. Header, trailer and header. So it's adding data trailer, DT, plus packet plus data header. So it's all combined link we called frame, data trailer, data header, not HD, DH. It's data header actually, sorry. Then what is exactly data trailer contains? DT contains CRC, cyclic redundancy check. To detect the error, it uses what? CRC help action. And data trailer contains about headers. Header contains about SRC, MAC address, source MAC address, DST, destination MAC address. Got it? So finally, data trailer plus packet plus data header, both combined we call it is frame. Segment to packet, packet to frame. So frames will generate in data link layer by adding of data trailer, data header to packet. So this is what exactly happening in data link layer. Application to presentation, presentation to session. Transport is adding transport header, which contains source and destination port numbers. So transport header plus data, we call it is segment, and segment will flow to next layer is network layer. Network layer have two protocols, which is routing and routed, and it is adding network headers which contain source and destination IP addresses. So network header plus segment, we call it is packet, and packet will go to next layer is data link layer. Data link layer, a device which is switch involves here. It will detect the errors using CRC protocol, which is cyclic redundancy check, to detect the errors. And even data link layer also adding headers and trailers, data trailer and data header. Data trailer contains, which is CRC, data header contains source and destination MAC address information. So data trailer, packet plus data header combined, we call it is frame, and frame will flow to next layer is physical layer. So in physical layer, your frames converts to bits. The frame will convert it to what? Bits. Say zeros and ones. Clear? So what type of devices involves in physical link? In physical layer, devices involves which is our cables and ICs, those things actually. So what type of media we have? This is a device. And what type of media? RJ45 cable you can connect. Means it's a copper media. Or we can connect network through Wi-Fi. Wi-Fi means what? Wireless media. Or we can connect through optical fiber media, OFC media. So based upon type of media which we are using, so here this is a source device. From source device you want to send some data. That is, hello, how are you, friend? Means application layer will involve here. The first thing is what? Application layer. Now presentation layer will come in the picture. It will provide standard format .txt files like this. Presentation layer. Now session layer will establish a sessions between the source and destination device. Now transport layer will come in the picture and it will find out whether the service is TCP or UDP. If it is a TCP, then three-way handshake process, connection established, then data traffic. Or if it is a UDP, no three-way handshake process, directly send out. Segmentation, multiplexing, sequencing is all that done by transport layer. What transport layer is doing is it's adding headers to data packet. We call it is segment. So segment will comes under transport layer. Now network layer will come in the picture. So what network layer will do? From source to destination device. Source to destination device. If you have the multiple paths. If you have multiple paths in source and destination device, it will find the best path using what?
Routing protocol.
Routing protocols. Using routing protocols, you'll find the best path actually. Yeah. Okay.
Sir, hello. What is the path, sir? Path mean?
Path selection. Best path means have the multiple routes to reach out the destination.
Okay.
You'll choose the best path, shortest path. Then you can get faster communication. So what is the website you open right now? To which website you're connected?
Zoom.
WebEx, right? WebEx.
Yeah.
WebEx.
Yeah. So your might be in Hyderabad. So where is WebEx server? WebEx server will mean like in UK, US, in different countries actually, correct? If you say US, from Hyderabad you connect it to WebEx server. So do you think from your computer to reach to WebEx server you have only one path? No,
Multiple.
there might be multiple paths. If you have a multiple paths, then traffic should go via shortest path now. Then who will find that best path? Routing protocols. Got it?
Yes, sir.
Yeah. So what network layer also is doing is it's adding network headers which contain source and destination IP addresses. So we call it is packet. And packet 2 in data link layer, what data link layer will do? It will run CRC protocol to find any errors in the packet contents. If no errors, will forward it. Or if it is errors, it will send back to transport. It will correct it actually. So to find that, to detect the error, data link layer will use what? CRC protocol. So that data trailer plus data headers, which is contain source and destination MAC, we call it is frame. Now in physical layer, what happened? Your frame is converted to what? Zeros and ones. Again, zeros and ones, what? Bits. Zeros and ones. Again, based upon the type of media which you are using, your bits are converted to signals based upon type of media. If it is a copper media, your zeros and ones are converted to electrical signals in different voltages. If it is wireless media, you are using Wi-Fi, then bits is converted to radio frequencies, RF waves. Or if it is optical fiber media, your bits are converted to light signals, light pulses. Based upon in different wavelengths actually. So this is what exactly happening in physical layer. This is layer 1. It defines electrical, mechanical, and functional specifications for communication between the network devices. It is a process of converting binary data into signals. Binary data means bits into signals based upon type of media. It is what? Based upon binary data into signals based upon the type of media, like copper media, fiber media, wireless media. For copper media, electrical signals of different voltages. Fiber media, light pulses of different wavelengths. Wireless media is radio frequency waves. So this is what exactly happening in physical electron. Okay. No doubts. See, in transport layer, what transport is doing is, whenever data comes to transport, what transport will do?
Check if it is TCP or if it is using TCP or UDP.
Okay. And before sending data packet to network next layer, what transport will do? It's adding transport headers, right? Similarly, what network layer is doing before sending a segment to next layer, what network layer is doing?
Header.
Network header.
It's adding network header. Even before data link layer, before sending a packet to next layer, what data link layer is doing? It's
Header.
also adding headers and trailer, right? So this process, adding headers to the data packet, this process we call encapsulation. Encapsulation is a process of adding header and trailer to the data for proper data transportation purpose. Yeah. So how data is happening is flowing from device A to device B, adding headers. Headers are added. This process we call encapsulation. So one encapsulation is done and it will come to physical link, which is bits. So it remove the headers, removing data trailer and header, removing network header, decapsulation. Finally, device A will send data, device B also will receive the data. But in the backend process is all the happening, encapsulation and decapsulation. Clear? Any doubts? So this is how exactly happening in data communication happening from one device to another device. Any doubts? It's clear. Okay. Can copy it. So let us understand the troubleshooting part. It's all your devices. All devices are connected to which device? We need one switch to centralize connectivity communication through wired. Now these users internally they can communicate, but now thing is traffic should go outside, I mean different network. Then we must require which device called
Router.
router. It is switch. Now switch to a router. Like users, how users can get communicate with public network. So we can connect with public network through ISP only. So we can take ISP help. ISPs are connected to internet actually. Here I have one general question. Example, at your homes, if you are not getting internet access, suddenly you lost internet connection. What generally we'll do? What is the basic troubleshoot we do?
Restart router.
Restart router. Excellent. That is universal troubleshoot. Everyone will do the same thing, correct? Yeah, if technical person, non-technical person, everyone will do what? If whenever you're not getting internet, we'll restart the router. But funny thing is, sometimes it will work. It works actually, correct? Okay, you have restarted your router. Still, you're not getting internet access. Then what we do?
Give a call to ISP.
So we'll wait for some time. Oh, it might be some problem with an ISP. We'll wait for some time, like 1 hour, 2 hours, like this. It's been 5 hours, but still you're not getting internet access. Now what we'll do? We'll make a phone call to ISP with loud voice. Correct? Then ISP will say, sorry for inconvenience. I'm sending some technician. Technician will come to home and will check something and will do it something. Now internet came up. Service charges 500 rupees. Agree everyone? This is what happening, right?
Yes.
Yeah. The thing is, if it is a home network, no problem. We can allow the users to get into access. But what if it is the office organization? So can you allow out of like service providers to an office premises? No, don't allow, right? Then how to troubleshoot? So before making a phone call to ISP, first we have to make sure there is a problem. So we need to troubleshoot. How to troubleshoot? Oh, it's elephant speed. What is layer 1? Cabling, connection. So layer 1 troubleshoot first. Like you need to check all connectivities. PC to switch connection, switch to router connection, router to ISP connection, like all connectivities to be checked. Okay? So I have started troubleshooting in L1. L1 is okay. Connectivity is okay, but still you're not getting internet. Then layer 2 troubleshoot. What is layer 2? Data link layer. Layer 2 is data link layer, which is switch. Like now, we need to log into switch and check switch maintain one table called MAC address table. So in MAC table, like MAC addresses information is available or not. All switch level configuration part need to be checked. And check communication from PC to switch, end user to L2. It is pinging, it is communication is okay. Then we can confirm that there is no problem in layer 2 also. But still you are not getting network. Now layer 3 troubleshoot. Next layer is what? Layer 3. Layer 3 is network layer. Which device involves router? So router also maintain one table called routing table, IP table. So this IP table contains source IP address and destination IP address. So router level troubleshoot now. Routing protocols, source IP, destination IP, router level troubleshoot. In router level also, no issues. Everything is good. Everything is fine. Next, immediately, who is the problem? No problem might be on ISP side. So before making ISP, then making a phone call to ISP, now we can check is all the troubleshooting action. If L1 and L2, L3 is perfectly all right, now we make a phone call or just drop a mail to ISP telling that our end, everything is being connectivity and communication is properly working. A problem might be your end, please check ISP. Then ISP will respond immediately. So we don't want to allow ISPs to our premises, office premises, actually, because we can't give the control our devices to ISP persons. Correct? So as a network engineers internally, we need to be troubleshoot our devices having problem and issues. So as a network engineer, our responsibility is this is our responsibility. This range we called CPE range. Call it is CPE, customer premises equipment. In customer premises equipment, like PCs are involved, cables are connected, L2 devices, L3 devices, these all things we need to be taken care about, our responsibility. Clear? So successfully we have completed network fundamentals, and tomorrow onwards we are going to do, starting discussing about layer 3 devices. Introduction to router, what is router, types of router, functions of router internal components, external components, router configuration, routing protocols implementation, all about routers only, means layer 3 devices and layer 3 protocols. We'll continue this week, completely this week, we are going to discuss about layer 3. Once layer 3 is done, then we'll go back to layer 2 devices, which is switch. So that is for 1 week. Then last week, how to protect our L2 devices, how to protect our L3 devices from different type of attacks. Like someone is trying to take a control of our devices, how to protect it. So that is our schedules, guys, actually. Okay. Yes, any doubts? I'll give one task for today. The small practicals will start. Lab 1. See this scenario. Device 1, device 2, device 3, 3 devices, plus 3 more devices, 6 devices, plus 6 devices. So first 6 devices are connected to one switch, and next 6 devices are connected to another switch. So first switch name is switch A, it is switch B. Device 1 connected to switch A, device 2, device 3, device 4, 5, 6 devices. Similarly here also device 1, device 2, device 3, 4, 5, 6 devices. Okay. Now for switch A devices has started assigning IP addresses 192.168.1.10, device 2 1.20, 1.30, 1.40, 1.50, 1.60, like this. For device switch B users, IP address 192.168, 2.10, 2.20, 2.20, 2.30, I mean 192.168, 2.30, 2.40, 2.50, and 2.60. Between device A, switch A to switch B also have made one link, uplink. They are connected. A and B are connected. This is a scenario, guys. Now tell me, device 1 and device 2, will they communicate?
No.
Okay. In switch A users, in all switch A users, will they communicate?
Yes.
Yes. Why? Because
Because
All are in.
all are in same network and connected with a switch.
Device B means switch B, all devices will they communicate?
Yes.
Yes. Because all they are in
Same switch.
Same network part.
same network and same switch. What about the switch A devices and switch B devices? Will they communicate?
They have to communicate with
One
router.
They don't communicate, right?
They do not communicate. To communicate, we have to use a router in between it.
Yes, but we don't have a router. As for this diagram, will they communicate?
Yes.
No.
This
No.
actually switch A connected to switch B, na sir, with cable.
Even, but switch cannot enable communication between different networks now.
Yes.
So they don't communicate. Actually, this is our practical. If you ping PC1 to PC2, PC3, PC4, 5, 6 devices in switch A, they can communicate. But when you trying to communicate, when you ping from PC switch A PC to switch B PC, they should not communicate. Actually, that is our practical. Because there is no router connected here. If router connected, then they can communicate. Actually.
If in same network, sir, same network, two switches, can they able to communicate?
Yes. The
Yes.
same network means if it is in switch A, is one device in switch A, one more device in switch 32 or switch C or switch D or switch C, they can communicate actually if all interlinked.
Okay, sir.
So this is our practical today. And similarly, one more practical. Make it is 2 copies. Same thing. Which is lab 2. Now for device A, switch A first device, you assign IP address in 201A colon 1111 :10. This is one IPv6 address. First device to same network 201A 1111 :20 :30 40 50 and 60. So now we made in all devices in same IPv6 network. In switch B 201A colon 2222 :10. First 64 bits are network bits, remember?
Yes.
So 201A 2222, 201A 1111. They are in same network or in different network?
Different network.
Different network. So they don't communicate actually without a router. So lab one is same network. Communication with IPv4. Lab 2 also same network communication with IPv6 network. This is your practical test for today. So to do these practices, number of how many pieces are required? How many cables are required? How many switches are required? How many computers?
Computers.
Yes.
Required. Maybe one cable is required. You can cut.
Why one cable? See the diagram now.
12 cables, sir.
12 cables.
12 pieces, 12 cables.
Yeah, 12 pages.
12 pieces, 13 cables.
Yeah,
Switch
13
A
cables.
to B also one link required.
Yes.
One upper.
Yeah, 2 switches are required, right?
Yes.
Switches required, 13 cables required, and PCs are like how many PCs we have? Like
12 PCs, 13
12
cables,
PCs.
and 2 switches.
Yeah, correct. Mhm.
So, what do you say? Purchase it today and do practices?
No,
Why, man? Then you need to practice now for a lab 1. 12 PCs required, 13
as you
cables.
said, there is software, right? Can we test on that software? One
Yeah.
which sure.
So all practicals can be done in software, which is a free Cisco Packet Tracer software. So in Cisco Packet Tracer emulation software, we can use number of PCs, number of cables, number of switches, number of routers also. Then we can feel like your real setup, like how you practice and how you configure your real routers, same as is you can feel actually. Okay, almost 98% same like your physical devices. Only thing is, in real time we can see the devices. Here we need to assume the device actually. Of course, in real time also we don't see devices because you are sitting in office, devices are in client location, right? Even remotely only you operate devices in real time also. So there's no differences if you practice in directly devices, if you practice in packet tracer software, almost same. I'll show you how to practice on packet tracer. So let me open this Cisco Packet Tracer student software. Already have installed, and I'm using 6.2 version, 6.2 version, which is a world one. Just a minute. So here, you can see end devices. This is PC. Click on PC. Click here. Click on PC. Click here. Like this. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 devices. Switches. You can take this switch, 2960 switch. Now connections. This is the connections. Generally, what cable you have to use between PC to switch?
RJ45.
PC to switch cable. RJ45 straight and cross, 2 types are there, right?
Yeah.
So straight cable for different type of devices. Between similar type of devices, cross cable.
Mhm.
So this is a straight cable, this is cross cable, this is fiber cable, phone cable, coaxial, DC, serial cable, different type of connections we have. Or you can use the first one. If you see first one is automatically choose connection type. If you use this, if you connect between PC to PC, it will be cross. If you connection between switch to switch, it will be cross. If you connect between PC to switch, it will be straight. So automatically it will choose based upon the device actually. Okay. You want to remove the cable, you can see the cross icon here. Delete. You can use this. Click on the cable. You can remove it actually. If you made any mistakes, you can use this actually. Okay. So I'm choosing automatic cable. Click on PC. Click on switch. Again, like this, we can automatic choose connection type. Connections also done. Switch to switch. Now assigning IP address. Click on PC. Desktop. IP configuration. IP address, as for example, 192.168.1.10. Like second computer. 1.20 like this. First switch B, same, it's 2.10. Correct? Yeah. Desktop IP configuration 2.20 like this. IPv6 example. I'm lost PC, I'm assigning IPv6. Here IPv6 201A colon 1111 60/64. IP configuration 201A colon 5500 50/64. Switch B devices. For switch B devices, IPv6 address 201A colon 2222:50/64. Last computer.
So we are setting up is everything in 64-bit kind of a configuration for.
Yes, all the 64 only. 201A colon 2222:60. 64 network bits. Yeah. Like this, we can assign IPv4 and IPv6. Let us check the communication now from first computer. Command prompt, fuzzy IP config. So my computer IP is 1.10. And I'm trying to reach out to my neighbor computer IP, which is 1.20. Yes, I can reply. I can get reply actually. Communication is possible. 0% loss. Packet sent 4, received 4, 0% loss. But when I'm communication to switch B user, which is 2.10,
We don't have, right?
we don't have.
Yeah.
See, 100% loss. Okay. No. No. Okay. So even from IPv6 also same thing. Ping 201A colon 1111:50. But when you try to check with 201A colon 2222:50, it won't communicate actually.
So because we don't have the connection with IPv6 with the 2222, correct?
Simple, we don't have a router. That's all.
Yes.
Because we are trying to communicate with different network from 1111, we are trying to reach out to 2222. Both are in different network now. So without a router, they don't communicate. So here we don't have a router. We connected to switch directly. So it won't be happen. Using router can communicate actually. Got it? Yeah. So it's a small practical. So try to practice on this software. You search in the software for in Google. You can easily found it and you can easily download and can easily install.
Which version need to install, sir?
Search in the Google Cisco Packet Tracer software. You do some exercises downloading and installing. If you're not able to do, so tomorrow I'll share that link actually to download it. Okay.
Sir, if server is in a different switch, sir, if they're not connected to my switch, when I ping the server, it says me that timeout can't reach out. Or can I ping in the office? Can I ping all the servers if
That
I
is
know the
what
server
your
IP address?
your PC IP and the server IP should be in same network or not?
Yes, sir. If same network, I can ping.
Yes.
But how do I check that sometimes internet is not working? Sometimes my database I'm not able to connect. Sometimes my web server I'm not able to connect. I know the IP
That
address.
is what. So your PC first it is connected to which device? Switch.
Okay, sir.
You should know switch device details actually. So you need to ping to switch. Up
Also,
to
IP address of
switch is
switch.
pinging. Yeah, you should know switch ping, switch details actually. It's IP address and all. If you are able to reach out to switch, means till switch, no issues. If, good, there is no problem in your computer and switch. And you know about your router also, your device, your office router IP also, and reach to gateway up to gateway. If it is reaching means there is no problem in internally, problem in outside actually.
If your server
But you
is
should know
not
the
responding,
details,
so
switches and
how do
routers.
how do I check, sir? I have a database. For example, I'm not able to connect to the SQL server.
See, if you are not able to connect the SQL server, there might be a lot of possibilities. A problem in SQL server or problem in your end or problem in between connectivity also. So we can't say exactly how to troubleshoot it. You should know the details, how the infrastructure connected, how your device is connected. Actually. One by one you need to check. In
Okay.
single point, we can't say actually it is. So do one thing, simple. From your device, if you're not able to access SQL, try from another device. In another device, if you're able to access means the problem in your device only. From another device also you're not able to access means there is a problem network issue.
Thank you.
All good. So it's all about for today, and tomorrow we'll continue with introduction to routers. Thank you. Have a good day.